In this video, we'll talk about the types of problems where you're asked to determine how to make a function continuous. So the last type of question that can come out with respect to continuity is the idea of figuring out what needs to happen for a function to be continuous, or how to make a function be continuous. And the way you go about this really comes from the definition of continuity. The definition is that, to review, limit x goes to c of f of x needs to equal f at c. Now, how do we make this happen? In general, this will be done with piecewise functions where there's a gap at c. So in that sense, you really need to think about the two one-sided limits independently. So to solve these problems, to determine what needs to happen for a function to be continuous, we need to compute three things. We need the limit as x goes to c from the left of f of x. We need the limit as x goes to c from the right of f of x, and we need the value of f at c. And these will all be determined based on the definition of the function that you are given. Then, to make it continuous, all three of these must equal the same number. Because remember, for continuity, the definition implies three things. The limit exists, the function's defined there, and all those values are equal. If 1 and 2 here match, namely the left and right hand limits match, that tells us that the limit itself exists. Then we find the value of the function at that point, and if the value here matches the combined value of these two, namely that the full limit exists and is that value, then the function is continuous at c. If we have this, then f will be continuous at c. Let's look at this idea in the context of an example. So determine the value of the constant c so that the function x squared minus 3 for x less equal to, and cx plus 2 for x bigger than 2 is continuous everywhere. Now this function is already continuous almost everywhere. And why is that? Well, this function x squared minus 3 is a polynomial. It's continuous, so I know that f is continuous for x less than 2. Everywhere less than 2, this is totally fine, it's nice and continuous. Same thing for x bigger than 2. No matter what c is, this is a linear function. It is also continuous. The only potential issue is where this definition changes at x equals 2. So we're going to focus on this point and compute our three things from before. So part 1 was the limit as x goes to c from the left of f of x, and here our c is 2. So what happens? Well, if I'm looking at x coming to 2 from the left, it means I only care about values for x less than 2, which is then focused on this part of the function here, because that's what it is for x less than 2. This will be the limit as x goes to 2 from the left of just x squared minus 3. But x squared minus 3 is a polynomial, it's continuous. So I can just plug in 2 to get 2 squared minus 3, or 1, for that answer. Part 2 was the limit as x goes to 2 from the right. By the same idea, I'm now focusing only on values of x bigger than 2, so it's these values here. This will be the limit as x goes to 2 from the right of cx plus 2, but this is linear. It's continuous, so I can now just plug in c times 2 plus 2, or 2c plus 2. And last thing I want is just f at 2. If I go back to the function, the equal sign is here, which means for 2, I'm just plugging into this side of the equation. This will be just 2 squared minus 3, or 1 again. Now to make this continuous, all three of these must match, which means I need 2c plus 2 equal to 1, 2c equals minus 1, or c equals minus 1/2. So for that value of c, this function will be continuous. So to summarize, f will be continuous everywhere if c equals minus 1/2. And we got that by looking at this function, figuring out where the problems could be, the only places where it could be discontinuous, and then computing these three components, the limit from the left, limit from the right, and the value at that point, and make sure they were all equal to get this function to be continuous with that certain choice of constant. That's the way you go about these problems. They are all about looking at the definition of continuity, what it implies, and then trying to figure out what needs to happen to satisfy that definition at the point in question.